So question 4 says use the remainder theorem to find the remainder of f of x when f of x is divided by x plus 4. Then use the factor theorem to determine whether x plus 4 is a factor of f of x. So again, down here, we have if a function is divided by x minus r, f of r is going to equal the remainder. So that's how we have x plus 4. Notice how I can write this as x minus a negative 4. That's the same thing as x plus 4. So notice that r is actually the opposite of this. So r is always going to be the opposite of what's being followed here. So if you see a plus 4, it's actually going to be a negative 4. If you see a negative 4, it's actually going to be a positive 4. So notice how our r is actually going to be this 4. So if I evaluate f of r, in other words, f of 4, it'll tell me what the remainder is if I divided this polynomial function by x plus 4. So we would put 4 into the function. That would be 4 times then 4 to the 6th power minus 64 times 4 to the 4th power plus 4 squared minus 20. So if you use the calculator, we have in 4 and then in parentheses 4 to the 6th power, come down, minus 64 in parentheses 4 to the 4th power, plus then 4 squared. I don't know the parentheses there since 4 is a positive value. And then minus 20. I think we've got that correct. Looks good. Hit enter. And also, I didn't want to do that one by hand. 4 to the 6th power is quite a bit of math. So we do actually end up with just this negative 4. So the question is x plus 4 a factor? Well, since the remainder was not 0, if it was 0, we would call x minus r a factor, or x plus 4 would be called the factor. But since we got a remainder of negative 4, this again would be a no. It's not a factor. So again, like I said, this saves us from doing long division. So if I was doing long division as a problem, I don't know if I can actually do this or not. Let's see here. X plus 4. Again, if you think you've had enough of this one, you can move on. But if you want to be kind of curious, let's just hang back and look a little bit more of this video. Notice how we have to actually watch out for placeholders. So we have this 4x to the 6th. We're missing the x to the 5th, so it doesn't matter what I put there, but I'm just going to put a plus 0x to the 5th. So since x to the 5th is missing, that means its coefficient was 0. And then minus the 64 x to the 4th. And notice how the x to the 3rd is missing, so I have like plus 0 x to the 3rd. Again, it doesn't matter if it's plus or minus because it's a 0. But then you have this minus 20. No, sorry, we're missing several more terms. The x squared would be there, so plus x squared would be there. So I do need a plus sign actually on those. I'm missing the x term, so a plus 0x. And then we have the minus 20 there. So again, if I'm doing this, we're asking ourselves, x plus 4 goes, and again, we're just going to do the front end. So what times x plus 4 gives me 4x to 6? Well, I would need 4x to the 5th there. So if we do that, we can now see that 4x to the 5th times x would be 4x to the 6th. 4x to the 5th times 4 would be 16x to the 5th plus 16x to the 5th. So remember, we're supposed to subtract those, but what you can do is just change the signs and actually just add. So I'm just going to change those both and then add. So what we're going to have then is these zero out, and this gives me a negative 16x to the 5th. Then I'm just going to bring down one more term. So then we come back up here and ask ourselves, instead of using division, we can go backwards and go, what times x to the 4th gives me this negative 16x to the 5th? Well, I would need a negative 16x to the 4th. So negative 16x to the 4th times x is going to give me negative 16x to the fifth. And then negative 16 times positive 4 would be a negative 64 x to the fourth. So then we want to change the signs. That turns into positive. That turns into positive. We want to add. So that all just zeroes out. So that's a 0. So we're now down to this x squared comes in. So really, we come all the way over here. So what times x gives me x squared would be an x. So x times x squared would be x squared. And x times 4 would be 4x. So the 0x, I may as well go ahead and bring it down too. So again, to work this, we have to change the signs and add. So that's going to zero out, and that gives me a negative 4x. And then this minus 20 comes down. So we do have this spot here. So what times x gives me negative 4x? Well, I'm going to need a positive 4 there. So positive, actually a negative 4, sorry. So negative 4 times x is negative 4x. So I need a negative 4 there. So negative 4 times x is negative 4x. And then negative 4 times 4 would be a positive 16, or negative 16, I'm sorry. But then we change the signs and add. That becomes a positive. That becomes a positive. So what we pick up on is we're going to have then the negative 4x, the 4x are going to zero out, and negative 20 plus 16 is going to be a negative 4. And now we're too small. So x times 1 gives me negative 4 is not, so that's going to give us our remainder. The remainder would be a negative 4. So what we actually would have would be 4x to the fifth minus 16x to the fourth plus x, or make that in purplish, plus x minus 4 would be our quotient, but there's a remainder of this negative 4 over here. So since we didn't go into it evenly, then it's not going to be a factor. So it does check out actually.